I'm recording. So, just remind me, please. You just told me that this topic we're on is called integers. Can you remind me what an integer is? Both?
It's a number, whether a negative or a positive number.
Dash?
It's a whole number.
It's a whole number. You said that, but you didn't put your hand up. It's a whole number that can be positive or negative. So we're dealing with whole numbers. No what. We don't need what in this topic. Decimals, fractions. Okay. And we're looking at how to work with integers, positives and negatives. Now, we looked at a number line last time. I see Sky has got his sheet from last time in front of him as well, with that number line with opposite numbers on it. That could be useful. So, today, we're going to look at absolute values. And practice 2 says, evaluate the absolute value of each of the following. Okay, so let me just write, we can do this as an example underneath. Straight line, straight vertical line, -2, straight vertical line. Kind of like brackets, but straight vertical, not curved. Okay? That might be new to you. This is called the absolute value of -2. That's how we say it. You want to write that down? I can pause. Now I'm going to tell you that the absolute value of -2 is equal to 2. No?
The positive number is equal to.
Well, let me write another one. Let's see. Let's do B. And let's see if you can pattern spot your criterion B. All right? So, next one is vertical lines with the number 12 in it. How would I say that? The absolute value of 12. Yeah. Right? The absolute value of 12. And that equals. What do you think, Brooklyn?
-12.
You think -12? Makes sense, right? It's actually 12. What do you think, Dash?
That if it's already. Oh, wait, was it 0? There's just 0? 0, 0.
Sorry, Dash.
I don't
know. No? Well, should we just do that one? The absolute value of 0 is?
0.
0. Let's do a couple more. The absolute value of -7 is?
7.
Actually, 7.
Just
7.
Isn't 7 on its own
7.
the same as positive 7?
So the absolute value of 7 is 7.
Yeah.
Any ideas what you think the meaning of the absolute value of a number is?
The regular number or a whole number? The regular.
They're all whole numbers, and regular mean, I don't know, what's regular?
Maybe just like regular, like 1, 2, 3, 4, 5. Maybe the positive version of.
Oh, okay. That's better than regular, isn't it? Bo said maybe the positive version of that number. So now that is a common way to express the absolute value, but it's not entirely correct. Absolute value, some people say you basically ignore the sign and it's always positive. But what I'm going to do is I'm going to give you the definition of the absolute value. All right? So you're going to write this down. This is going to be your important bit. The absolute value of any number is the distance of that number from 0. Does that make sense?
Wait, if it was like, let's say it was 5 out of 12, or like
So how far from 0 is 12?
12.
Well, how far from 0 is negative 7?
7.
7.
0 is like a bit.
It's the opposite direction, isn't it? But it's not, we don't say negative because distance is always expressed as a positive number. Like, for instance, how far, and I know this because we cycled it the other day, how far is it to Admiralty House Park? Well, I know it's about 4 kilometres. How far is it to the golf course in the opposite direction, like John Smith's? It's about 6 kilometres. Now, they're in opposite directions, but we don't say one is positive or negative. We just say it's that far or it's that far. What do we add in real world to give a sense of direction?
Miles, kilometers.
Well, that's a distance, but direction. We could use a compass, which would be, we could say that maybe left or right changes, doesn't it? Where's my left?
Your left is my left. Yeah.
Exactly. So we have measurement labels like east or west. They never change, right? Now that's important for our next question. So we do have things that replace positive and negative words like east, west, north, south. Okay? You wrote that. Okay, but the absolute value is simply like it's that. It's how far away is that number from 0. So just to maybe visualize that, on a number line, right, which you've already worked on. So we would say that 0 is in the middle, right? Positive 7 would be up there. Negative 7 is the opposite, right? Absolute value is how far. So the absolute value of 7 is that distance, which is 7. The absolute value of negative 7 is the distance from 0. Okay? Doesn't matter whether it's up or down. Alright? And like I've already said, we do use this concept in terms of how far we have to travel. Skylar, have you joined us? Because I don't know whether you can do it with your ear. Have you joined us? Basically, we're asking what is larger, absolute value of negative 7 or 3?
Absolutely.
Okay, that is larger because if we do the absolute value of negative 7 is 7, and 7 is larger than 3. Now, Bo asked the question which was
0, 1.
the 0 one, but I can equally do that for a negative 6. Those two are not absolute values, they are just the numbers. So which one's larger? What's larger? The absolute value of 4? Absolute value of 5?
6.
6.
Oh, wait.
Yeah, that one's larger. Can you see why people say, oh, if you just ignore the negative, you're all good?
Yeah.
Alright? Because basically, if you just ignore that that negative's there, you've got. But the problem with that is in this situation, like when they're both numbers, if you start ignoring negative numbers, then negative signs, you're in trouble. What sign goes between negative 8, the absolute value of negative 8, and the absolute value? They are equal. Negative 10, negative 3.
Oh.
Because this is negative 5, not the absolute. Okay.
And it's equal.
Okay. We got the idea of absolute values. We're not going to spend too long on this. This is kind of it for absolute values. We will want to kind of work in situations where this concept is applied. So, in the next question it says here, all been to Manhattan, wandered round, avoided the crowds, had a hot dog from the very dodgy hot dog stall, rushed to the bathroom afterwards. Alright, I am going to ask you please, are you all okay to read through those questions first? Like spend 2 minutes reading all the questions to get an idea of what it's asking you. I did add a picture, just that it's not the whole of Manhattan, but it gives you an idea of what it's getting at. Right. So have a read. It says, assuming all city blocks are the same length. Now that is actually an important point, and they don't make a big enough thing, but maybe you could explain it in a little bit. It says, how should the distance between 231 East 41st and 5th Avenue compare to the distance between 231 West 41st? So what they're saying is, if we go down to 41st Street, which is with Avenue T, makes sense? Alright? Do you know what they mean by 231? It's a house number, right? Technically. So let's just say, is that 45? Well, yeah. Let's say that is there. That's 231 East 41st. Where would 231 West be? Okay. This is why they're saying, assuming that all the streets and houses are the same distance. Okay, so that would be at West 41st. Right. So, what's the answer to their question? How should the distance compare? They should be the distance. You can't have opposite distances, but you can have distances that are the same. So the answer to question B is the distances should be the same. Yeah. Now, looking at that, explain how you could use integers in addresses instead of east and west. That's the next section. If you were not allowed to have east and west, what would you call 231 east compared to 200? They've got to have different addresses. Right and left. So the problem with that is, if I come down south to it, I would go left. But if I'm coming from south up north, I would go the other side. So we'd have to have another, like, left is always, we've got a better way.
Question.
Yeah.
Let's say you're driving up right here. You're driving up right here.
Can you give me a number? So
Let's say you're driving up right here. Like just like right here.
yeah.
Or like right there. And then it tells you to go west. Which you would still go that way, and they would both be west, right?
Yes, but I know that 231 east is east of
Oh.
5th Avenue rather than east of me. Now, I guess we could say left and right in the same way, could we?
Yeah.
But left and right change depending on if I come down or if I'm going up. Whereas east and west never change, do they? So could we use, when it's saying use integers, can you think, what does that mean? What type of integers do we have? Well,
Like 0 and what's the base?
so if zero's in the middle, what are either side of zero? Positive and negative, no?
So you do like negative 231.
Could it be like that? So 231 West 41st Street could be negative 231, not 204, I'm getting that mixed up. Could that be how it works?
Yeah.
Just, and I don't need the west, right? What would 231 East 41st Street be? Well, if this was the negative, what would this one be? Oh, so could we just write that as 231 41st Street? Does that make sense? So if, as Dash said right from the beginning, if we make Fifth Avenue 0, anything on the west side is
Negative.
negatives. Because remember, we have a number line, don't we? If we write it as a, if I put in the 0 like that, these would be -1, -2, and these would be 1, 2, 3, and so on. So the west side would be the negatives, east side positive. Making sense? Over to you. A couple of minutes to have a think. Tell the person on the table with you. Suggest 2 reasons why east and west are used instead of negative numbers. A couple of minutes.
Because everybody knows